Hi everyone. In this question, we want to find the possible values of the constant k such that the equation kx squared plus 4kx plus 3k plus 1 equals 0 has two different real roots. To do this question, you need to understand about the discriminant. This table shows how we can use the discriminant to determine the number of roots that a quadratic equation has. You may recognize b squared minus 4ac as part of the quadratic formula. When that particular value is negative, so less than 0, we'll have no real roots. If the discriminant is equal to 0, we have one distinct real root, or we may call that two equal real roots as well. If the discriminant is positive, we'll have two distinct real roots. And you may have questions where the discriminant may be greater than 0 or equal to 0. And you may see this referred to as real roots. So that could be one root or two roots. When we read our question again, we see it refers to two different real roots. Different being distinct. So we'll be considering the third discriminant here. So let's see how we can use the discriminant to solve this problem. The first thing to do, we'll write down our question again, which is kx squared plus 4kx plus 3k plus 1 equals 0. So let's compare that to the quadratic equation, which is ax squared plus bx plus c equals 0. So when we compare them, we can see that a equals k, b equals 4k, and c equals 3k plus 1. So the next step is to write down your required discriminant, which is b squared minus 4ac is greater than 0. So now we have an inequality we're going to need to solve. You will need to substitute the values into the inequality now. So we'll have 4k all squared minus 4 times k times 3k plus 1 greater than 0. So let's simplify. We'll have 16k squared minus 4k times 3k plus 1 greater than 0. So when we simplify further, we'll have 16k squared minus 12k squared minus 4k greater than 0, which will give us 4k squared minus 4k greater than 0. Now we can factorize a little. We'll have 4k bracket k minus 1 greater than 0. So what you need to do now is find the values of k that will make this inequality true. Let's try the test point method. So for this method, we'll write down the equation again, but we'll let it equal to 0. So 4k, k minus 1 equals 0. When you try to solve that equation, you'll get k equals 0 or k equals 1. Those are the roots of your equation, but we can also call them critical points. So let's put those critical points on a real number line. Here's our number line. So we have 0, let's put that there. 1, 2, and let's use also negative 1. So to solve the problem, we need to refer back to our original inequality and look at that when we're dealing with this number line. The first thing you need to consider is whether k equals 0 and k equals 1 are parts of your solution. Now to do that, we'll substitute them back to your inequality. So you would have 4 times 0 times 0 minus 1 greater than 0. And is this true or false? So we'll have 0 times negative 1 greater than 0. We'll have 0 greater than 0. So 0 is not greater than 0, so this is false. That means k equals 0 is not part of your solution. So we'll do an open circle there. Let's do the same for k equals 1. We have 4 times 1 times 1 minus 1 greater than 0. Is this true or false? Well, 4 ones are 4, and 1 minus 1 is 0. So again, we're going to have 0 greater than 0, which is false. So we'll put an open circle here as well. So both 0 and 1 are not part of the solution. So now we look at some other numbers on the number line. So let's try 2 as a test point. So let's put 2 back into the inequality. We'll have 4 times 2 times 2 minus 1 greater than 0. Is this true or false? 4 2s are 8 times 1 greater than 0. 8 greater than 0, which is true. So 2 is going to be part of your solution. So let's just put a tick there. You will find that if you try some other numbers that are greater than 2, they're all going to be true. I'll let you try that yourself. So let's try a number in between 0 and 1, in between the critical points. So let's try a half. So put half into your inequality. We'll have 4 times a half times a half minus 1. Greater than 0 or not? 4 times a half is 2 times half minus 1, negative a half, which is negative 1. Negative 1 greater than 0. That's going to be false, isn't it? That's not true. So let's try one last number. Let's try negative 1, which is on the left side of the critical point. So let's sub in negative 1 to your inequality. We have 4 times negative 1 times negative 1 minus 1 greater than 0. 4 times negative 1, negative 4. Negative 1 subtract 1, which is negative 2, which will be 8, which is indeed greater than 0. This is true. Negative 1 is true, and you will find that negative 2, negative 3, and so on will also be true. So the result from this number line will tell us that A can be greater than 1, or A is going to be less than 0. And this is your final solution for K. Thanks for watching.